start the stream.
Start the stream. Let's start the talk. Let's get things going. I went to POPL'26 2 months ago and I haven't mentioned it since I came back. So I thought it was probably about time I discussed what I did. Just to double check, everyone in this room knows what POPL is? Yep.
In theory, I know in theory.
Principles of Programming Languages. Giant conference, one of the big boys. It was fun. Okay, there we go. It was in Rennes, in France, and it was in this building, which was very nice. They made a very nice logo of it. It's called Couvent des Jacobins. Sorry, Guillaume. Which is a 14th century convent turned into an exhibition centre, and they were doing a lot of work on it while we were there. It was nice. It was a really pretty little village town. We ate a hell of a lot of crepes in Brittany. I pretty much never want to see another pancake in my life. But yeah, the food was good. The conference was nice. The place was nice. How did I even get there? By student volunteering, because the tickets were like £700, £800 a person. Definitely check the schedule beforehand to sign up for my shifts, and I can see you all looking at the picture and wondering. I was with a couple of other volunteers, and we were all together, like, all right, the picture's going to be taken in 15 minutes. We're going to get down there. And then we got lost in a conversation, and we were 3 minutes late. And they'd just taken the picture. I still have the shirt to prove it, that I was there. Just not in this picture. It was so upsetting. Yes, a lot of these people. I know I was talking with it was Kim from Edinburgh who I was having a conversation with, so we both missed it.
I see her. Am I crazy? Or is that just someone that looks like her?
No, that is her. Then who was I talking with? Oh my god. This is why I should have given the talk immediately when I came back instead of merging everyone in my heads together.
The guy who looks like you. Someone I know.
It looks like Kim? Is that what you're saying?
No, it is not Kim.
Oh, it's not Kim.
No, Santa hat is not Kim. Yeah. But the other person could still be Kim. Like,
yeah.
There's a big, Kim could be here.
Kim could be here, or she could be in the corridor here running with me to try and make the picture. Which is Santa. Yeah, I don't know, they were all fun. There was a mixture of postgraduates and undergraduates as well, which was interesting and fun. But anyway, what I want to say is, although I missed the picture, that was because I was having quite an interesting conversation with some people, which is probably one of the main reasons to actually go to POPL or a massive conference in the first place, which is to just have a lot of conversations with a bunch of new people. There are lots of activities to kind of break the ice, because sometimes it's very nervous trying to talk to a lot of people and introduce yourself constantly. One of my favorite activities was this Jane Street was one of the sponsors of POPL, as they quite often are, because it's one of the most richest functional programming places. Pardon?
Richest places.
Just richest places, yeah, period, sure. But also, that just so happens to be interested in PL, sometimes vaguely, sometimes actually. But that board game night that they did was actually really, really fun. They're and I think it was a very good way to break the ice and kind of get interacting with people and moving around the tables and stuff. Yeah, and we even got to take some of the board games home because they didn't want to pack it in all the way back to the US. But unfortunately, my suitcase was already full, so I think there's some people who are going back on the train fighting for them. But I mean, meeting new people is hard, so sometimes it's actually just nice to hang out with the people that you know. Like I said, I was talking with some people from Edinburgh and Glasgow that I'd met once at an SPLS, and suddenly you see someone you know, you meet eyes, you're like, okay, there we go. Merge yourself. And it's quite nice to kind of have that distinction of kind of meeting new people, building up that acquaintances, but also kind of like solidifying and strengthening your friendships with other people, and you can kind of get into deeper conversations. But yeah, and I mean, other people that you want to talk to is people whose talks that you liked, because they're obviously going to have something interesting to say. So a lot of times you can kind of, I found it a bit weird at first, that you could just kind of go up to someone who's like obviously your senior in every way and just like harass them for an hour at lunch or over dinner, but people did it. And even if there's like talks that are really popular, right, that's everyone wants to go harass these people, you can just find someone else who also like the talk and just kind of talk with them. And those are also really interesting conversations, because you got to kind of, rather than being like sitting down and like, you're the authority on this subject, please talk to me, you kind of got a bit more on a one-to-one level, which is really nice. And of course, there's the actual presentations themselves as, I mean, what people might think of the main reason why going to POPL, although you can just look them up in your own time. But there's kind of, I'd say like a distinction between the presentations. Some are like the big, chunky technical ones, but there is a lot of ones about sort of like these softer skills, these kind of easier, more general ones about like writing papers, about just being a researcher in general. And those ones are actually some of the most interesting ones, to be honest, because they give your brain a break from like thinking about all of this insane maths that's coming in. But yeah, I think I'm next going to talk about one of my favourite talks on the softer thing, which was called Weak Accept by Alex Cabos. I think someone's heard. No? This was like a PLMW talk. So PLMW, Programming Languages Mentoring Workshop. They also provide travel funding and registration funding if you can get it. Unfortunately, I did not get it, so I had to be a volunteer. But there are multiple avenues to getting it. And then MSP thankfully funded my travel. Thank you very much. Yeah, Weak Accept. Basically, it was Alex talking about, Alex Cabos is a professor at the University of Bristol, and very great, good researcher, and also a very good speaker. But he was basically talking about his response to reviews on his paper, and that Weak Accept is probably, in his opinion, one of the worst responses you can get to a paper that you've submitted, because it doesn't say anything. And if you just get Weak Accept, your paper is not going to be accepted in whatsoever. So it kind of is just basically like, on a form, just pressing middle of the road for everything. You haven't kind of read it. But in terms of if you actually get good feedback, he kind of gave some really negative. Started off with this thing, which might seem kind of really horrible, You're already feeling down. You're like, no, why? This isn't my fault. And you're actually, no, yeah, it is your fault. But this kind of idea is to try and anticipate like any negative response. If you say you get a bad review, right? And the review is literally just like, I didn't understand it, or the review is just about like, in the review, you can see that the person has like a fundamental misunderstanding of your work. To be honest, that isn't their fault, that's your fault for not making it clear enough. You can kind of think of it like that. And so one of the responses you can do, maybe not to directly target that feedback and go, I should implement this obviously wrong idea that they have, but to try and make your own ideas clearer so that these kind of miscommunications can't happen. So be defensive when you're writing. But despite that, you are not bad. Don't take it too personally. Don't try and get defensive. Take a breath. It's your research is not the end of the world. It's not the end of you. Kind of. I'm not saying this as good as he does, obviously. But yeah.
I think it's easy to say.
Yeah, exactly. You are. Yeah.
Has anyone here ever actually had a review that just read Giga Scrub? So that's not what it's about.
Yeah.
Yes, you have to do that, but it doesn't mean you're bad in practice.
Yeah, exactly. It's sometimes you write bad work, right? Sometimes you write a bad abstract and or you do a bit of research that's a bit rubbish. That's just human. It doesn't mean that you are a bad researcher.
Connecting with an audience takes a model of the audience, not just an idea about work. That's one reason why gigging, tour the material with smaller audiences, see what actually connects in the room before you try and figure out what to write down on the page.
Yeah. That's definitely a good idea. I think that comes up a little bit later in both the talk and this one. But I think this is kind of the idea of maybe almost expanding your model of the audience to include people of various levels. So one of the things was make sure there's something for everyone in here. From the lowly first year PhDs or final year undergrads who don't really have that big of a background, who, the world leading experts, and everyone in between, kind of build it up and make sure that even if not everyone might understand or comprehend the entire thing, but make sure there is something for everyone.
Unless, of course, you're submitting to a category theory venue. When you should engage in the most grotesque vocabulary.
Oh, God.
And the review is this was done on Mediograph Notes to the Australian Catholic Theory Seminar. I found it in my drawer.
It was once already revealed to me in a dream.
I mean, I don't know, maybe that could be a good motivation. A little children's story at the beginning of your dream of all these abstract categories made into some real thing. But another thing, kind of more of an anticipation of bad reviews, is to make your contribution really explicit. And so this is something I've noticed. I think when I was doing my final year undergrads back in 2020, I didn't notice this as much. But now, when I'm reading papers, you see literal, in the first or second sections, bullet points of everything that they do in this paper that is new and novel. I mean, it is a bit more in this essay I will, etc., but...
Yeah, I think it's terrible writing. And what I was always tempted to do is to put them in at the review stage, because busy reviewers are not the same thing as normal readers, right? Normal readers who know that they're going to read about this idea want to be told a life story.
Exactly.
Right? Whereas people with a pile of 20 papers to review want to figure out as quickly as possible whether it does anything they care about.
Yeah.
Yes.
Yeah, whether it does anything new or novel. And I mean, there is definitely a way to do this without bullet pointing every new thing in your paper. Especially in the abstract, I think it's a good idea to kind of give your overview of the story, maybe end with your new thing. But
I remember reading some advice from, I think it might have been Olin Shivers on PhD dissertation writing, where he said, in his opinion, the very first sentence of your dissertation should be, in this work I will do. And I mean, I don't know, I followed the advice of my master's thesis and it seemed to work.
Yeah, and
it got me my PhD here. So.
That's true. That is true. I guess it's I mean, we aren't doing English degrees, right? But there is something to be said for having a nice writing style, I think, and
Yeah,
But I mean, it's just that it struck me that
Yeah.
that's the same advice, you know, make it really explicit.
Yeah.
What the scope of what you're doing is, and most of what you're not doing. What's
yeah, that's also definitely a good idea.
And
Like,
so instead, when the PhD examination comes up,
yeah,
and they ask you, why haven't you considered such and such, you can just say, I said right on the first page of
Yeah.
my thesis, I'm not considering this.
yeah, that's got to be a good feeling, you know, absolutely sticking it to the reviewer with something that's already in there. Oh,
Of course, your most important reader is the red panelist, in which case you do all the bullet points. Describing this.
Back to the years. I turned 55, 2028.
General view.
Your favorites.
As someone who only reads papers, I will say subjectively, I do like the kind of almost bullet points in the abstract, but in the introduction, I do prefer what Connor says
oh, interesting.
about a
Yeah.
story. You kind of said the opposite, which is that like in the abstract you should have more background, and then maybe in the introduction you have the bullet points. But at least subjectively, when I'm looking at an abstract, I'm trying to find the thing that I'm looking for. I'm not committed to reading it. Once I get to the introduction, I'm reading it. So I want the story.
I mean, that
I
makes
guess that's
sense
a
to
good
me.
point. Yeah.
I mean, yeah, it's a I mean, there's like multiple parallel,
Yeah.
paths through a paper
That's
for
true.
different audiences.
Yeah.
And in that case, it might even make sense to like, present the same information in two different formats, right? Like, here you
Yeah.
go, here's some bullet points if you want to read those. Here's a
Yeah.
story if you want a story.
Yeah, exactly.
Well, I mean,
mean-
this kind of happens with talks sometimes, where the talk is like, we'll have a slide that is almost like the bullet points,
Yeah.
which the person talks through, but then like the paper might be in a completely different style.
Yeah.
In fact, this actually reminds me, I don't know if this is such a big thing in computer science, but I've noticed some journals in the natural sciences, I think especially of science,
Yeah.
they will have the article, and then they will have an abstract, and then they will have like an abstract of the abstract, which is bizarre, like in two different styles. It's like a there's like a readable abstract, and
Yeah.
there's the abstract that actually submitted. And I mean, I can't see the point of it. I reckon that if you want an abstract wants to be readable in and of itself,
Yes.
if you have to rewrite the abstract to make it readable to that abstract, but it seems to be the way it's done. And
That's interesting.
yeah, I mean, I think there's definitely an advantage of having the abstract be pitched at a slightly different level.
Yeah.
Jan online says the most read parts of a paper in order are title, abstract, introduction, conclusion, and body. And so
Yes.
This is
I
fun.
was.
really.
Ooh.
Yes. You read the title, then you read the author, then you read the references to find out how much you want to kill them. Then you
I was going to bring up that sometimes I do look at the conclusion first or after the introduction, because it sometimes gives you a bit more of a concise thing of. It's like a rewriting of the introduction, but shorter.
I mean, it bothers me a lot.
Pardon?
I like it for the section headings.
That's true.
That's an overview of what's the paper.
Although sometimes
And
the
we also
section
do the
headings can be.
size of each section as well. So every technical, it's 2 pages, and then there's a lot of waffle before that.
I was just reading a paper this morning that had a technical bit of half a page, and it was just all writing, and it was crazy.
But then the technical bit is too long, and then the waffle is not there, then some reviewer will complain, oh, why did you not introduce it, otherwise I have to go to
The journal of functional programming used to have capsule reviews written by one of the reviewers. So they'd have the abstract and a capsule review or something like that. More to the point.
Yeah.
I remember.
This is a question from someone who doesn't rate things. I'm curious, is there a reason why shorter things never like have table of contents? Because I really like a table of contents for exactly the reason you're saying, but I feel like they only exist for longer things.
One thing is the dissertation, right? The table of contents.
Yeah, and then a lot of times in your PDF reader, you can just open up like the side view.
The articles are in a large body.
Yeah.
Each article is a bit like a magazine. It's only recently they've swollen the image. In the PDF.
Yeah. More in terms of writing, there's been lots of papers where you see something in the introduction and they say, and they, you know, hint something really cool, and then it's just never expanded upon, ever. So if this kind of brings it into a little point of,
Essentially, it's done reviews by ticking off the introduction.
Yeah.
Make sure you actually.
Yeah, exactly like that. But sometimes you might even like imply something in the introduction and then it just goes on, which might be a symptom of writing the introduction last a lot of times. Because if you would write the introduction first, or at the very least like an overview of your project, of your research, then most times you're not going to accidentally sort of be like at the end going, oh yeah, that would have been a cool thing to do. Let me write that down and then never do it.
Someone else writes the introduction. That's their big idea.
Yeah.
Don't quite match up.
Yeah.
That's to do the research. Also, yeah, people write the introduction fast.
Yeah.
It was written in half an hour.
Yeah. That's true.
The rest of the thing is well.
Yeah. Which I think kind of almost comes into what you were saying kind of earlier about having your big idea and then trying to test it out on audiences and seeing what sticks as well. This is kind of like a mini one, like, I don't know, almost a sort of paper version of rubber ducking it, you know, like giving the presentation to yourself, seeing what you find important, and then on rereading it back and then trying to edit things down.
The same thing happens for a PhD thesis. I recommend writing the introduction in between each chapter. You know, first and last, right? Redraft.
Yeah.
Redraft the introduction constantly.
Interesting.
That's a good idea. I should try and write introduction right now and see what happens.
It's also a read driven verb.
Yes.
That's
true. And how long until we have prompted introductions? And by have, I mean how many papers already currently have AI written introductions? Terrifying. But yeah, this was a great paper.
We're going to finally get literate programming in the mainstream. Silver linings.
The journey was a product optimization machines.
Yeah. Oh, that was something I'm trying to like get into the first years. Is that to me, you write code for other human beings and yourself, not for machines. You know, it's the primary thing, but difficult. Anyway, look up. There's various recordings of Alex Kelos doing this talk and other things. So I can't remember. Don't think I've linked it here, but I can link it as well, like I have done for other talks. Another talk I went to was a talk about the evolution of effects by Nick Woos, another kind of soft one, which I skipped part of PLMW to go see, little conversion, but they were doing like an industry panel and some quantum talk, so I thought, let's go and see what happens. All the way back from, I think, down to like Church versus Turing style programming, all the way up to sort of current algebraic effects. It was a really fun talk. It kind of followed a little bit the development of Haskell and GHC, and you know, the nice photo of all the people doing there. This was kind of in its like 5th iteration of the talk, 4th or 5th. Because every time he kind of gave this talk, someone in the audience would shout, I was there, and it didn't happen like that. Disclaimer, I don't know if SPJ ever was at one of these talks and shouted that, but I just thought this was a fun little idea of from poking his head around the corner to shout at someone. And also the little tidbit that the start of algebraic affection, I think, maybe happened in like the 30s or something with Genson's sort of sequent calculus and stuff. But actually, it was back in the 71,000 BC with this lovely little rock in found in South Africa, which you might be able to see is like the double lambda sign up there.
Great.
Yeah. The earliest known abstract drawing of man was actually a prediction of all that's to come in functional programming. Yes, go look at the entire talk. I'm not going to give the entire history of effects right now, but this was actually a really fun talk. Link the POPL'26 one because the 26 one, the audio got corrupted, apparently. So, unfortunate, but I mean, maybe in this one someone will shout out, you know, have SPJ's head coming around the corner in this one. But enough of the soft stuff. Let's get into some of the best papers that I saw, at the least from my perspective. People here might have some different opinions, but kind of picked out 4 that I really liked. One about hyperfunctions, lazy linearity, big stop semantics, and quotient polymorphism. I think all of these also have just nice titles, memorable. And these are all links as well, so I can give you these. But also, if none of these catch your eye, then I'd encourage you to just go look at the program and see what takes your fancy, because that's how I made my schedule. All right. What is a hyperfunction? It's this weird little arrow, kind of this weird, infinitely left-nested function type from A to B to A to B to A to B. Kind of think of it.
Oh, wait. That's some kind of transducer.
Yes. There you go.
What?
A transducer.
It's a transducer?
So something that can augment transversable things.
It's like one of the 2 players, right?
Yeah. So, you know, if you want to collapse like you don't want to go over a list with like map and then filter, you want to kind of do every time you see an element, you kind of want to do your operation on that. And kind of things. But yeah, you kind of think of it in fixed point syntax, a little bit like this, where you can kind of swap the arguments around there, which is quite nice. So basically this work was about this kind of almost literature review of where these things come up, starting from transducers and essentially trying to transducify zip, because it's quite easy to see how you do, like, you know, 1 passes over lists, kind of augment these things into like a fold and do these things, but if you want to do 2 at the same time, you go, oh, what do I do? And so this one came up in that regard. It's kind of so this kind of goes over a bit of this classic example of these things where your original idea of like a map, you know, just does these things. You pattern match on the nil case, you pattern match on the cons case, and you do some stuff and you have a recursive call. And then you can kind of translate that into a fold by having your nil case as your base one. And you kind of see this as like a destructed cons here. You do your thing on the X, and then you, instead of a recursive call, you just do add in your original one. And so you can kind of do this for filter as well. Oh, whoops, double clicked. By doing, you know, the same thing, basically. How would you do this for zip? Turns out if you try and do it for zip, you, especially in Haskell, you get this type error. So if you try to do kind of like 2 fold Rs over your 2 lists, You get this funky looking Haskell GHC infinite type error, which is exactly this.
Right.
So if you literally just say new type, you know, A to this, like this thing, then it just all works. So go check out the paper for how I think this actually works, how you get this code. Check out the talk for more examples of these things in the wild. There's lots of fun things that it has. And I think the talk was just well given and well demonstrated. So yeah, if you're confused, go look at the talk. All right, laziness. So, okay, look at this code that is basically in lazy Haskell, kind of with the lazy combinator here. Is A, the variable A, used linearly here?
Hopefully.
Haskell was a lazy language.
One would hope, but I guess no, maybe.
Can I take and assume something this force? Is that right?
Yeah. I think in the example they had like a pointer and like deallocating a pointer. So this kind of idea of using.
But it's a lazy let.
Yes.
So the B consumption only happens if B under the let is executed.
Mm-hmm.
Then of course there's also the question of what the type of if then else is.
Yeah, that's true.
My guess is it should be, but it's not.
That's pretty much right. The semantically, if you were to disable type checking and execute this program, then yes, it would be used linearly. Mm-hmm. But right now, Haskell's type system does not allow this. Right. It does, so lazy Haskell in particular is an extension of Haskell with linear types. But yeah, linear Haskell. I keep saying lazy.
Which is not just Haskell. I think if you use the newest Haskell version, I think you just. I guess maybe you need to turn on a language exception.
Yeah.
Does it complain that you don't use B in much branches by any chance?
No.
Because B here is like a non-linear variable. We're just considering A as the
No, the complaint is that you're using A because it checks linearity in a very dumb way.
It doesn't know when it's branching.
Yeah, exactly.
Yeah. So actually what someone came up with then at this talk was a type system for GHC core, so that accounts for laziness. Because things like this, although this code, by a human would probably never write it, a compiler optimization might generate this code. And if you go through the talk, then the speaker will actually give you some examples of some compiler optimized generated code that breaks, that fails to type check even though the original code type checks in lazy Haskell, which is obviously terrible and breaks semantics. So they came up with a new type system in core. This is kind of what you might originally think of a linear type system of doing. So say you have some non-linear context, and then you have some linear context that you split into. You type E1 using the first one, and you type E2 using the second one, while also having X in the linear context of the second one. This one would break with the original code.
I'm also not sure I agree with you that a human wouldn't write things. No, about the previous slide. I was just saying, I don't agree with you that a human wouldn't write something like that. In that, I think it'll also fail if we have a different function here. And if you have some long expression which contains A, I could very realistically see myself writing this.
Yeah, that's
something
true.
Like this. And
you should always be able to take an expression.
Yeah, exactly. You should always be able to Yeah.
So,
Yeah.
I mean.
And that's just even, I guess, even more fuel for the fire.
Yeah.
Right? Even more motivation.
Right.
But anyway, with this one, the difference here is that we're not allowed to reuse the original context in here, and also we must use the bound variable linearly. So what if we don't do that? And so this was their proposed type system. We still split the context, and we do the same thing where we evaluate this guy linearly in this context. But what we do is we don't then consume it. We allow our second expression to use this context, and we add x in to the nonlinear context. We can reference x as much as we want. However, we kind of subscript it with this. Any time that we use x, we must consume the context that was used to generate it.
So lazy let is a win in a sense.
Is a what, sir?
A win in linear logic is
Yes.
conjunction where you only get to use one of these lines.
I think so. I need to
Yeah.
look that up, but it is.
It puts the linearity constraint kind of on a different party essentially.
Yes, exactly. It allows you to, so it allows you to kind of consume this context whenever x is consumed. It doesn't assume that this context is being consumed at evaluating E1. So I haven't given you the var rule here, but you can imagine that if you have a var
Also,
of
even
this.
against these X, so you have to find a way of using all of that.
Yeah.
Yeah. So maybe I should have put the var one here, but if you had like gamma x sub delta 1 and delta 1 in your context, then you can type this.
I don't understand how it's like that.
Well, more you could have B with delta 1 for if you instead of having this notation.
Yeah.
You could build a
Okay.
new thing.
Yeah.
So it's
And-
not there.
Yeah. So it's like B with delta 1.
Yeah.
When you're asking.
Well, yeah, and here you don't need projections and stuff. It's either,
Yeah, and it
more.
Note to modern people. If you see a type system which cuts the context like this, throw it in the bin. It's worthless. You need an extra layer of indirection to show resources being cut up, right, in general. Right, this whole business of is making stuff kind of heavily reorderable in ways that's not long-term sustainable. So, what's going on here is that you have multiple ways to consume the same resources.
yes.
And it's so yeah, I think it's right to identify this problem. I think there's also a problem with if then else. I can see what's going on here is to push everything into how the context is bookkeeping, what's alive and what's not. The variables rulers are presumably doing weird shit like deleting things
Yes.
in the context whenever you look at other things. And that's another bad smell because you don't tell the context tells you.
Well, in this case, the context is telling you because the context here says that it needs delta 1. Although, the difference here is that we are labeling contexts, which is weird.
Like if you read it bottom up, you need to decide how to cut up the delta 1 and the delta 2.
Yeah.
Substitution.
Ooh, that's a good question. Let me.
Yeah, I mean, I'm saying that something in this direction may prove to be important, but it's setting off many of my bad design.
Yeah.
Sense
That did not work. Okay, that's cool. That's fine.
I mean, it's hard to do good things when you're constrained by tacking it onto a pre-existing.
I realise I'm not sharing this actually on the Zoom.
It is very easy to not notice just how much Haskell fixes for you in advance when you start watching things like this onto it specifically as well.
Yeah, but the point here though is that okay, I mean it is 1 foot on the platform and the other on the train. You know, if you want it to be a GHC plugin, then you're
Yeah, it is definitely not implemented.
I mean, it's been the whole story of kind of GHC core is we have to design it badly if we want to do it now. And it's produced decades of terrible work rather than mere years of good work. And an entire industry of ghastly things which make incremental progress in the wrong direction, paper after paper after paper.
Okay, but you've now had 2 decades worth of people who showed up for a PhD, might not have known what they were doing in a development exact language, may have spelled the GADT, but knew what one of those was, even if GHC doesn't compile them reliably yet.
Does it say in section 4?
I too am old enough to remember when GHC core didn't collations involved in the GADT and just inserted on set collations everywhere.
I'm curious what progress in the right direction would look like. If what we've had is progress in the wrong direction.
Actual linear logic, I guess.
I'd like to read it.
I'll also post the links to all these papers.
I guess they didn't prove any substitution of things.
Yeah.
It's operational staffing, so substitute variables for variables. Because it's making new functions.
Yeah.
So we never come up with a problem of substituting an expression for a variable. Just going to try and substitute.
Yeah.
Via that delta one into context.
Yes.
Well, that delta one is in 2 something.
That's true.
What's the big sigma on the way out? This is new alien.
Does it say anything up here? Type and context for expressions in sigma.
Nice, yes.
Some kind of multi-use.
I'm sorry, so what are we?
So maybe we should just do an entire MSP 101 when we take a look at this paper and revision it.
I definitely think like now might not be the right time for it.
Yes, exactly. I think this is meant to be a whirlwind through interesting things.
Yeah.
If there are interesting things.
So we have about 10 minutes.
Yes. Yep, that's fine. I think I've got a couple more things to do. Alrighty, let's I'm not on the right thing. Where the fuck is my, there we go. Cool. Alright. We can talk about lazy linearity in a bit. There's 2 more papers that I wanted to show off. This was a fun one called Big Stop Semantics. In terms of operational semantics, you have two main players. You have big step and you have small step. Big step kind of terminates, right? You have an expression, and big step operational semantics says how that reduces into a value. So by necessity, it has to terminate in terms of like being its value. But a lot of times, the derivations are a lot shorter, and especially like I think the actual authors of the talk kind of gave some like benchmarks in terms of lines of ACTA code for these kind of case studies that they had.
Like it must terminate, either it terminates
or it's
doesn't.
yes.
The difference between use forever.
Yeah.
It's just
Yeah, and you can't, for example, like partially evaluate. Yeah, you can't prove things about non-terminating expressions. Other than it doesn't terminate, right? That's the only thing you can say about it. So in terms of like actually interesting properties that you can prove about big step semantics and derivations, most of them must terminate if you want to actually do anything useful with it. On the other hand, so then you might say, okay, well then if I'm developing my own operational semantics, I'm going to use short step, small step, because they don't have to terminate, right? But a lot of times it leads to a lot more complications where you kind of have to carry around these contexts while you're doing things, and a lot of other kind of bookkeeping. Again, they gave more examples in the talk. Especially in terms of these benchmarks. So wouldn't it be nice if we could do something to combine these two into something that has the best of both worlds? Big stop semantics. So I've kind of done this weird little arrow here. They use a different one. I couldn't find the LaTeX symbol for it.
What one did they use?
It's like this weird curly down one. I don't know. I think so. Or it's like this triple one. But anyway, there's basically one that says they don't always have to terminate as a value. And a lot of times you'll have these non-deterministic, essentially, derivations where you can derive something multiple ways. So an example here is an application where you might say, okay, this is kind of like a normal application derivation for like lambda calculus, right? You reduce the left side to a value, and then you partially maybe reduce the right side to another expression. But what if the left side doesn't reduce? Or we just want to partially reduce it, right? Then we have another rule, which says that we can partially reduce the left side. And we can keep going. So essentially, at the bottom line, you choose where you want to stop your evaluation, and then you produce the proof that it's partially evaluates to this. Which I thought was actually a really cool, I don't know, it's interesting. It's kind of, there's not one way to evaluate and derive the semantics for a particular expression, which might be, I don't know, a downside in some ways, but like with a lot of times with small step and big step, you can just kind of whack them. There's only going to be, at most one evaluation step that you can perform at any expression, whereas here you can do multiple. There's also one where you can just, stop immediately. You don't evaluate anything, such as if you just wanted to evaluate that to a value. And they gave some nice benchmarks for it. It's apparently a little bit larger, more lines than Big Step, not by like marginally, but allows, and they prove in the paper, allows the same properties that you can prove with Small Step that you can prove with Big Stop, which is nice and fun. So yeah, they have some more examples of other rules in the paper and in the talk. Yeah.
the idea that you had a small step semantics, then you can relate two expressions with this.
Yes.
If there was a path.
Yeah. If there was a path in small
smaller
step.
derivation.
Yeah.
The steps.
Yes, exactly.
Correctness with respect to some steps.
Yes, exactly. So if you have some sound small step semantics, that's, you know, where E in some steps really reduces to like E prime, then you can evaluate E using big stop to E prime with some sound derivation. And then it preserves sort of other properties as well, I think, type preservation, and they do a lot of other things as well with it.
Give a systematic way of translating from the other.
That's a good question. They didn't talk about that in the talk, but I mean, it sounds like there should be, right? You just.
I mean, you look at these two rules, and if you're me, you spot a differential operator at work.
Yes.
So it's a dissection. We're very definitely biased as to what's left of the cursor and what's right of the cursor. So the first rule says the cursor has visited the function completely and is now somewhere in the argument.
Yeah.
Whereas the second rule says the cursor is still somewhere in the function and hasn't reached the argument yet.
Yeah.
So it's all about, indeed, you know, where spatially in this term did the thing stop?
It's like the idea of holes, context holes.
Yes.
Basically.
All of which connects strongly to the differential structure with the underlying syntax.
Also, imagine that small step semantics, you're adding transitivity in our field. It's we can change steps together. Seems like this is pushing transitivity into being invisible material.
Yes.
Yeah.
Yeah. This is, you can't.
It's a useful fit for any relation.
Yeah.
I want reflexive transitive closure. And I build that in instead of having it.
That's a good point. Yeah. And I think there's also kind of like philosophically a difference with small step. You keep doing it, and once you've done the original thing, like you say when to stop, you can kind of choose at any point when to stop evaluating. Whereas here, you've got the entire expression, and you have to choose the exact kind of point in it that you want to stop and then build up. You can't keep going essentially. If you use this one, you can't then use this derivation to build up to this one. You have to already have to start with doing this derivation. I think more of a syntactic sort of restriction on it. I mean, you could probably translate extend this one into this one, but again, there's kind of this difference there. All right, I know we're at the end. There's one more little thing that I want to talk about if there's time. Sweet. Which is final one, which was another like GHC extension kind of talk, like the lazy one, about quotient Haskell. Does anyone know what quotient Haskell is? All right. So we have liquid. There we go. So many L words, unfortunately. We have liquid Haskell, right? Refinement types where we say, you know, a list. We want a list, except you can reorder the elements, right? This is kind of similar, where I have a bag, which is a list, quotiented by this equality. and then say a set is the bag, except you can, you know, idempotence. How is this different from liquid Haskell in what's fundamental way? When you create a value in liquid Haskell of a refinement type, say I have a natural number, right? And I declare that to be a refinement type of the integers that's greater than 0 or greater than or equal to 0. When I construct a value of this natural number, I have to provide the proof that it's greater than or equal to 0, but I can just extract out the underlying integer at any moment. There's not there. This is kind of the other way around. So say if I had a natural number which was quotiented by minus x equals x, integers quotiented by that, I can just chuck in any number. I can construct a number and I don't have to worry, I don't have to provide any proof, right? Because I can throw at it a negative number and it will just do the quotient for me. When I eliminate a value of that, then I have to prove that I'm mapping every element in an equivalence class to the same thing when I try and get it out. So say I want to do some like nat, some function on nat, then I have to make sure that that function does the same thing for every equivalence class. So it's kind of putting the burden of proof further down the line. It's interesting. The trouble with quotient types at the moment is that we can't really parameterize over them. So you might think that, okay, I have a bag and a set, and so I should be able to, you know, change every element in it. So I should be able to map, you know, everything over a bag, and I should be able to map everything over a set, lowercase set there. But essentially, it's doing the same thing all the time. These functions shouldn't be fundamentally different. I shouldn't have to write a new function every time I do this. Right now you have to. We should have some kind of idea of polymorphism in the quotient on the type that I'm using. So something a little bit like this. But then you have to think about what, yes.
Just a little, I'm not sure I agree that the functions aren't fundamentally different. I mean, the map and map back are pretty similar, but map set, like let's say if you give your mapping function as being const 1, for instance, then it's just going to collapse the whole list into a single value. A whole set into a single value. It's quotiented on uniqueness. Like it's not.
That's true.
Like you're no longer preserving all the properties that you think you're preserving.
That's true, but that only matters when you actually try and get an element out of the original, the later set.
Isn't the whole point of the sentence that you don't want to be storing multiple values in the first place? Like to me, when I would use it, because I want
I mean, that makes sense. Maybe this is a bad example of like an IRL quotient that you might want.
This is not the Haskell set, it's a quotient.
Yeah.
So the representation is really cheap to have.
Yeah.
It's expensive.
Yes, exactly. It's a good example for like giving an idea of what quotients are and how to use them.
But I guess, all right, so when you define a quotient data type, it's syntax.
Yeah.
So like it's, like how does that actually work? If underlying representation remains the same,
yeah,
then what actually changes with the quotient?
The changes with the quotient is when you actually try to use this. So adding, like Bob said, adding to a set, like an element to a set, is really easy. You don't need to check that the element's already in a set. When you're using the set, or especially like a property of the set, like what is the size? Yeah, exactly. What's the size of this set? Then you need to consider that the quotient element should not be counted twice.
Yeah.
So then how does that consideration work? Because presumably it defeats the purpose if you would have to rewrite, say, the length function.
So that function should.
Yeah.
Yeah.
There are some functions that you shouldn't have to rewrite, and there are some functions that you should. And so essentially what this paper is doing is trying to give a way so that you can polymorphize these quotients in like a type-safe way, so that the ones that you do have to rewrite, for example, map set, which does change the length. So you can kind of think about, you know, if you were to give, where's the...
Hold on, then I see another problem, I think. So let's say you have this definition of set. It says x cons x cons x's is equal to x cons x's.
Yes.
So now if you have a length function, which you haven't rewritten, then it seems to me that, you know, when you apply length to both sides of the equality, you want the results to stay the same. I'm forgetting what the technical term is, extensionality.
Yeah.
But then suddenly you're breaking that. If you can define a quotient.
So there's no definable length because it's an equality and not.
Yeah.
So you cannot apply length to a set because you know.
All right.
Exactly. So say you.
All right. Sorry. So there's separate types, right?
Yes. Yeah. These are separate types.
All right.
So say I have length written. Say I have length written for a list, right? I can then prove via like induction, right, that the length of this equals the length of that. Apply it to this quotient. But if I had to do the original one with the length of this does not equal length of that, therefore I cannot extend length.
So this is the bit I was missing, right?
Yeah.
Is a separate type, it's not a type synonym.
Yes. Yes. Sorry.
This is. It says data, right? All right.
Yeah, I think if this was a type synonym, then yeah, you would be.
Yeah.
Oh no, that's okay. But then, yeah.
Yeah. All right. So now I can see.
So basically, what we need to do is try and find a way of getting these, of finding the correct quotients that validate this and don't invalidate their quotient invariant. Check out the paper and the talk for how they do that. Sorry, it doesn't.
So quite curious. Is there going to be some things like bags where what's going on is only that there's some permutation group back to compositions, and then there are other situations where you're unavoidably talking about the equality of the elements stored in the positions. That's a whole other different thing. So there are going to be trade-offs here about which sorts of quotients you do with which sorts of operations.
Yeah.
That's how those trade-offs are negotiated. It looks quite curious.
We're thinking about performance trade-offs, about ordered list.
I mean, at this stage, performance issues file under a nice problem to have. At the moment, we're just trying to tell the truth.
Life is normal.
Yeah, that's all I want to talk about from POPL right now. So I hope that. Thank you. When and where is the next one? The next one is in January 2027, and it is in New Mexico. Not New. I always say that. I always say New Mexico, Mexico City. This is like the third time I've done this. I don't know why. Sorry, Mexico City. So, yeah, looks exciting. Although, yes.
A little bit of a bigger ask for MSP to fund.
Yeah, exactly, right, rather than a train.
I guess a question. This is kind of how I would expect quotients to work coming from mathematics. Where usually kind of define it as an equivalence relation, and then when you work with it, you have to prove that everything you do on it is well defined. Is there a reason that tools like Liquid Haskell use the kind of other way around? Is the the starting point, I guess, is my question.
That's a good question. Does anyone more entrenched in?
It's easier to listen.
Yeah.
Liquid has full like refinement.
Yeah, refinement types. So I mean,
Refinement types are about subsets. And
Yeah.
subsets are behaving quite dual weight quotients.
yeah.
So this is a whole other game, right? Where what kicks you is when you look at things, you see too much, and then you have to prove that you didn't care.
I mean, it's also, I mean, we are familiar with the fact that like co-limits are more difficult than limits.
Okay,
Right.
fair enough.
Yeah, it might be easier for a programmer to understand. So the more constructivist arguments of I have a natural number, that means it is definitely above 0, rather than I have to prove that these two things eventually map to something else. You know, you can kind of put it into the refinement type and out the refinement type as you will.
Yeah.
As long as you have to prove that it's above 0.
So how do you do that particular case with quotient types?
For natural numbers, I would have an integer, and then my quotient would be that minus x equals x.
Oh, of course. Yeah, I definitely say from program specs that's.
Yeah, it's
intuitive.
yeah, exactly right. It's a bit weird, and especially like for the things that you want to do with it, like I want to index into a list, right? But when all my negative indices must be my positive indices, it's a bit doesn't really make as much sense as the other way around.
It could be mods, right, for this syntactic JavaScript thing to access.
Yeah, that's true.
Negative numbers.
So that's true. I guess maybe if you have some, I don't know. I mean, that's just like a ring module. That's like a quotient ring then, right? Where you have like if 10 is your maximum, then 9 is the same as -1.
Yeah,
It's
like you know, modular arithmetic is quotient.
Mm.
It should be built in.
Exactly, right? Yeah. That sounds exactly this.
What was explained about one where you might allow the starting point to pretty brown, but it's but
I got it.
written shapes. Those are really
Yeah.